Hello and welcome to the review of Exponents. Some of this might be review, some of it might be new to you, but you'll need to know it for your Exponents benchmark quiz. The first thing we'll expect you to know is all of your powers of 2. So 2, 4, 8, 16, 32, 64, 128, and 256. We'll both want you to know these forwards and backwards. So I want you to know that 2 to the 7th is 128. I also want you to know that the 7th root of 128 is equal to 2. Also, similarly, the 4th root of 16 will be 2. I want you to know your powers of 3, but we don't expect you to know as many. Just up to the 3, 9, 27, and 81. Also, likewise, if I asked you the cubed root of 27, I'd expect you to know that the answer is 3. We want you to know all of your perfect squares, and all of you should know your perfect squares up to 10. They usually start to get a little bit fuzzy right here. So 121, 144, 169, 196, and 225. If you don't know them, write them down and memorize them. Also, you need to know your perfect cubes. 1 cubed is 1, then 8, 27, 64, 125. You could learn past 5, but this is all we expect you to know for your quiz. All right, now we'll get into the actual laws of exponents. And I know that you've seen these before. If I have the same bases and I'm multiplying different exponents, I add them together. If I have the same bases when I'm dividing them and they have different exponents, I subtract those exponents. And if I take a base to an exponent to another exponent, I multiply those two values. Now, if I have ab to the m, I can distribute that to both of the variables that are inside the parentheses, and that goes for whether it's rational or just whole numbers. All right, so after each question I do here, pause it, work through the problem in your group, and then play it to get the answer. So this answer is 2 to the 6th, because we have 2 times 2 for this first part times 2 times 2 times 2 times 2 for the second one. So really you have 6 2's that you're multiplying together, or we have 2 to the 6th power. Now 2 to the 6th power, some people might have it memorized off the top of their head. Some people might need to go 2, 4, 8, 16, 32, 64. Either way, the answer is 64. 5 to the 5th over 5 to the 3rd, that's 5. From our formula, we're going to take 5 to the 5 minus 3, which is 2, or get 25. And to think about this, if you forget the formula, remember that 5 to the 5th is 5 times 5 times 5 times 5. And then divide that by 5 times 5 times 5. Now 5 divided by 5 is 1. That's another 1. And that's another 1. So 5 times 5 will be 25. 2 squared to the 3rd power. Now in this situation, we multiply them. So we have 2 to the 6th again to get 64. Or what we can think of this as is 2 squared times 2 squared times 2 squared. Or we can think of that as 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the 6th, which is 64. 7 6 squared. 7 squared over getting ahead of myself, over 6 squared, which would be 49 over 36. 5 over 2 squared. I would just take this and go 5 to the 4th power, and take this to the 3rd power. So this would be 125 over 64. Now we're going to learn about other exponents, exponents that are 0, negative, or fractional. A to the 0, so any number to the 0 power is equal to 1. So the reason why that would be is, let's follow this pattern. So if I have 8 or 2 to the 4th, that's 16. 2 to the 3rd is 8. 2 squared is 4. 2 to the 1st power is 2. So each time I'm dividing by 2, dividing by 2, dividing by 2. So 2 divided by 2 is going to be 1. Also, if you think about it as 7 to the 3rd divided by 7 to the 3rd power, this is the same as 7 to the 3 minus 3, which is 7 to the 0. So any number over any number is just going to be 1. That's another way to think about why anything to the 0 power is 1. All right, so if we simplify this, 9 to the 0, 1. 5 squared is 25, so our answer is 25. A to the negative n is equal to 1 over a to the n. So if we follow this pattern down, we got to here. And if we keep dividing by 2, 2 to the negative 1, remember we're dividing by 2, so that would be 1 over 2. 2 to the negative 2 will be 1 over, if we divide 1/2 by 2, that would be 1/4. 2 to the negative 3 would be 1/8. And if, hopefully you can see 1/4 is 1 over 2 squared. This is 1 over 2 to the 3rd power. 2 to the negative 4 would be 1 over 2 to the 4th, or 1 over 16. And that pattern keeps continuing. All right, now simplify this without a calculator. What you do is 1 over 27, because it's 1 over 3 to the 3rd. 99 to the 0 power is 1. Now 2 to the negative 10th over 2 to the negative 7th. Now there's a couple ways to deal with this. One way is to say that 2 to the negative 10 is like 1 over 2 to the 10th. 2 to the negative 7th is 1 over 2 to the 7th. And when you're dividing fractions, 1 over 2 to the 10th divided by 1 over 2 to the 7th, that becomes, you multiply by the reciprocal, so 2 to the 7th over 1, so that's going to be 2 to the 7th over 2 to the 10th, which is 1 over 2 to the 3rd, or 2 to the negative 3rd, which is 1 over 8. I did a lot of work in there. Not all of it was entirely necessary. One thing that we can take out of this is we can go from here to there pretty quickly. Whenever you have a negative on one side of a fraction bar, you can put it on the other side, so from the top to the bottom or the bottom to the top, if we change the sign. So I could have just put 2 to the 7th on the top, 2 to the 10th on the bottom, and make them positive, and then it's easy to do it. Also, method number 3, which is what I would have done if I'm not trying to teach you a lesson here, I could just do 10 minus negative 7. So this would be 2 to the negative 10 minus a negative 7. Minus a negative turns to a positive. So this is 2 to the negative 3, which is 1 over 8. So multiple different ways. I just wanted to show you that 2 to the negative 10 over 2 to the negative 7 is the same as 2 to the 7th over 2 to the 10th. All right, a little long-winded. Try this one out. All right, this 2 is what confuses a lot of people. We take 2 times, this would be 1 over 5 squared, which is 25. So when you multiply fractions, 2 times 1 is 2. 1 times 25 is 25. So our answer is 2 over 25. In this one, we have 4 to the negative 1 over 3 to the negative 1. Like I said, we can flip those. So it would be 3 to the first over 4 to the first. And to the first power doesn't really do much, so the answer is just 3/4. All right. Now if we take 2 to the negative third power, if I bring that into the denominator, I have to have a 1 up here. So it'd be 2 squared times 2 to the third. That's going to be 1 over 2 to the fifth. Now 2 to the fifth, hopefully people remember, is 32. So 1 over 32. 2/3 to the negative third, that's like 2 to the negative 3 over 3 to the negative 3. So that's 3/3 over 2/3. Or sorry, I said that wrong. 3 to the third power over 2 to the third power, which would be 27 over 8. Now, fractional exponents are talking about square roots. So a to the 1 over n, is the nth root of a. So if we evaluate this expression, really we're looking for the square root of 9, which is 3. This one, we're looking for the third root of negative 125. What number can we multiply by itself 3 times to get 125? And that answer has to be negative 5. 16 to the 1/4. What number can I multiply by itself 4 times to get 16? The answer has to be 2. 49 to the negative 1/2. All right, now we're combining a couple things. So the negative, I can just write this as 1 over 49 to the 1/2. 49 to the 1/2 is the square root of 49. So this answer is 1 over 7. 27 over 125 to the 1/3 power. That means I have 27 to the 1/3 over 125 to the 1/3. So this is the third root of 27 divided by the third root of 125, which would be 3 over 5. So 3/5 is our answer. Now this one gets tricky again because it has a couple different things. We have that negative is going to be a negative 1 to each of these. So it's like I can just flip it over when I see that negative and then act as if it's positive. So I can just put a positive 1/2 in each of these exponents. So that's the square root. So the square root of 64 is 8. The square root of 49 is 7. Now if I have a number on top of the n, the top part is a power and the bottom part is a root. So 27 to the 2/3, what that's saying is 27, the cubed root of 27 squared. The cubed root of 27 is 3. Square that, and you get 9. Now we could try this another way. We could say 27 squared and then cube root that. 27 squared. Now I don't know that off the top of my head. We could figure it out pretty quick. So that's supposed to be a 9. It is right. So 729. Now if I take the cubed root of 729, I'm pretty sure that we'll get 9. To check it, 9 times 9 is 81. 81 times 9 should be 729. Looks good. So you can do them in either way. Either you can do the cubed root first or square it first. As you can see, in this instance, it was easier to do the cubed root first. All right, 4 to the 5 halves. I can take the square root of 4 pretty easy, so I'll do that first, and then I'll take that to the 5th power. So now that's just 2 to the 5th, so we have 32 for an answer. Now we have a fraction. What we could do is cube root all of these first. So the cube root of 8 is 2. The cubed root of 27 is 3. If I square that, it would be 4/9. Now we get into variables. So we use the same rules. X squared times x to the 5th is x to the 7th. Now try this one. This would be x to the 3rd times x to the 8th. Now when you multiply it, you add the two exponents, so it's x to the 11th. All right, 2r squared to the 3rd power. Now everything in here goes to the 3rd power, so it's 2 to the 3rd power times r squared to the 3rd power. So this would be 8r to the 6th. Now this gets confusing for people because they see fractions and they get scared, but this is actually pretty easy. You just combine those two by addition. So 4 plus 2 is 6, and the denominator stays the same. So 6/3 is 2. Now we're starting to get into a little bit trickier situations. You just multiply like terms. 3 times 2 is 6. X squared times x is x to the 3rd. Y to the 5th times y to the 3rd is y to the 8th. All right. 5 times 3 is 15. Oh, why can't I do that one? I made a mistake. I was going too quickly and I didn't see this squared. So let's square all of this first. This will be 25a squared, b to the 6th. And I'm going to multiply that by 3 times a to the 3rd. So I can multiply the 25 times 3 to get 75. A squared times a to the 3rd is a to the 5th, multiplied by b to the 6th. All right, now we take each of these to the 3rd power. 8 to the 3rd, that's the cubed root, which is 2. M to the 6th power times to the 3rd power would be, you multiply those, so m squared, and this would just be n, multiplied by 7m to the 3rd. 2 times 7 is 14. M squared times m to the 3rd is m to the 5th. And we have an n. All right, 3 x's on top are going to cancel out with 3 x's on the bottom. So it would be 2 over x to the 4th. Now this denominator, we can pull it up here. So it would be 4p to the 3rd, p squared. So it would be 4p to the 5th. In this situation, we take everything to the 4th power. So this would be c to the 4th over d to the 8th. Nothing we can simplify there. Now here we have r squared to the half power. So if I multiply that, that would be just r to the 1st power. And now if I look at the denominator, this would be s to the negative 1/6. So if I bring it up here, it would be r times s to the 1/6 in the numerator. And s to the 1/6 is the 6th root of s, so it doesn't really matter which way you write it. Here we have fractions up and down, so the 4 stays in place. This would be 5/3 minus 1/3, so that would be 4/3 as my exponent. All right. Now we start to get a little trickier. There's more stuff in here. This negative is going to flip everything. So let's do that first. 2x over 3x to the negative third y. Now that will be to the second power. So if I take everything to the second power, that's going to be 4x squared over 9x to the negative 6 y squared. Now this x to the negative 6 can go to my numerator. So I'll have 4x squared, x to the 6th. The 9 is stuck on the bottom with the y squared. Now I can just simplify these two to be x to the 8th over 9y squared. All right, now I'll start with this mess. That negative 1 is going to flip everything around, so I have 5a to the negative 5th over a to the negative third b squared times 3ab to the third. Now what I'd do is I'd flip my a's around. So I'd have 5a to the third over a to the 5th b squared times 3ab cubed. Here I would cancel 3 a's on top with 3 a's on the bottom, so I'd have 5 over a squared b squared times 3ab to the third, and this would be like over 1. So if I multiplied that out, it would be 15ab to the third over a squared b squared. Now these a's would cancel out, leaving 1a left on the bottom. These b's would cancel out, leaving 1 on top. So 15b over a is our answer. All right, last problem. This negative, we'll flip it over, so I have 9/100ths to the 3/2. I could take the square root of both of them to get rid of the divided by 2, so that would be 3/10 to the third power, which 3 to the third power is 27. 10 times 10 times 10 is 1,000. All right, that's it. Hopefully this was a good review of exponents. Your homework is on a worksheet.